Hello again. For those of you who have been following along all year, we've got yet another review video. In fact, we've got this one and two more yet. We've got units 5, 6, and 7, and we're also probably starting to wind down the year. So these review videos are probably more and more important. Perhaps as you start to prepare for the end of the year, you go back and watch the other review videos just to refresh yourself with some of the questions. But Unit 5 here, like I said with the last video, I thought Unit 4 ended nicely the first half of what we teach algebra-wise. I think this is the start, in my opinion, of the second half, dealing more with variables rather than equations and dealing with expressions rather than equations. So as you can see here, we start out with our exponent rules, which was one of the first things that we talked about in Unit 5. So the first rule we talked about was when we multiply like bases, we can simplify that by adding the exponents together. So I can turn that into an x to the 11th, and that's because x to the 9th really means, right, an exponent is repeated multiplication. I've got an x here multiplied by itself 9 times. And then I've got another x multiplied by itself 2 times, and all of those x's I can combine, and I can say that there's an x multiplied by itself 11 times. So we can do the same with the y's. Technically there's a 1 here, so that would be y to the 3rd. So we end up with an x to the 11th, y to the 3rd. And then just don't forget, you're still multiplying coefficients like you've always multiplied coefficients. Okay, so 4 times 5 is 20 every single day of the week. Okay, nothing changes there. We have our 20, x to the 11th, y to the 3rd. And that would be simplified because I have variables with positive exponents. I can't combine opposite, or not even opposite, I can't combine different variables. That's the best I can do. Number 2 deals with both the power rule and the product rule. So we just did the product rule. The power rule says when I raise an exponent to an exponent, I can shortcut that by multiplying those. So that's going to turn into an a to the 24th, b to the 8th. And just like the coefficients up in number 1, coefficients are dealt with how we've always done this. This is a 4 to the 4th. That means I've got 4 times 4 times 4 times 4. Okay? I can follow it through with the same rules if I wanted to. Technically, that's a 4 to the 1st, and when I raise an exponent to an exponent, I multiply, and I would get 4 to the 4th, so I can treat it the same way. I would rather you, though, just go to your calculator and plug that in. That's 4 to the 4th, not 4 times 4. It's 4 times 4 times 4 times 4, 4 times. Okay, so it's slightly different. The answer is not 16. It's a lot bigger than 16. Okay, it's actually a 256. Now, don't forget, all of that was in parentheses. I still have a 3a to the 4th, which now I can multiply these just like I did above. So that's going to give me an a to the 28th. It's going to give me a b to the 8th. And then I can multiply my coefficients together 3 times 256. So 3 times 200 is 6, so that's 750. That's going to give me a 768. A to the 28th, b to the 8th. Number 3 has us dealing with our quotient rule, which is when we divide like bases. So let's start with the coefficients this time. Dividing 30 by 12 reduces that into a 5 over 2. 6 goes into 30 5 times, 6 goes into 12 2 times. And then I can divide my similar bases, and when I do, I subtract the exponents. So that gives me an x to the negative 5th and a y to the 4th. There are other ways to do that. I think this is the easiest, just to simplify things. Okay. I then have to deal with negative exponents because you're not allowed to have negative exponents in your final answer. So I can move that to the other side is how I explained it to people. A negative exponent is repeated division. So if I divide, that's going to move that down to the denominator. The 5 stays. The y to the 4th stays. The 2 stays. Don't move more than you should. The only thing that's going to move is a base that has a negative exponent. So that's really what number 4 is all about. Just deal with negative exponents. It's a tricky question though. I throw a negative coefficient. We don't have any rules for negative coefficients. That doesn't need to move. Only move bases with negative exponents, which is why the x and the y moved down. But the z didn't have to move at a positive exponent, and the negative 17 doesn't have a negative exponent, so I leave it where it's at. So that was your review with exponents. Then we started to multiply polynomials, now that we were familiar with how we could multiply variables. So I have a blanket here that's rectangular, and letter A, actually, before we even multiply, just started practice adding like terms and using variables, things like that. Find the perimeter. Perimeter would be to add up all the sides. So remember, with a rectangle, opposite sides are equal. So that's also 2x minus 4, and the top would also be x plus 1. And if I add all these up, I have a 2x plus an x, which is 3, plus 2, which is 5, plus another one is 6 x's. They're like terms. I can combine those. And then the constants can be combined. A negative 4 plus 1, well, that's a negative 3. Minus 4 is a negative 7. Plus 1 is a negative 6. So 6x minus 6 would be my final answer for the perimeter. Letter B says find the area. Area would be length times width. So I would take that x plus 1 and I would multiply it by the 2x minus 4. I called these problems double distributing. Not only do you need to distribute the x to both terms in the next quantity, but you also have to distribute the 1 to both terms in the next quantity. So starting with the x times 2x is a 2x squared. X times the negative 4 is a negative 4x. 1 times 2x is 2x. And 1 times a negative 4 is a negative 4. And then you should always get used to adding like terms. Always double check your values here. Do you have any like terms? And when you do, you should combine them to make your answer as simplified as possible. Last question with this. You have the same style blanket, so it's still rectangular, has a different width and different length though. Write a polynomial expression that's simplified that expresses the difference. Difference means to subtract the area of size 2 and size 3. So size 2 we found already. Here's size 2's area right here. So that means I got to find size 3's area. Well, size 3 has a different width and length. So let's multiply those together. So start by distributing the 2x. That gives me an 8x squared minus a 20x. Then I have to distribute the 10, which is going to give me a 40x minus 100. Combine any like terms if there are, and there definitely are. So here's the size 3's area. There's size 2's area. I need to find the difference. So let's take the larger one, size 3, and subtract the smaller one, size 2. Negative 100 minus a negative 4. Remember, when you subtract a negative number, it's like adding. So that's going to take me to a negative 96. 20 minus a negative. Again, when you subtract a negative, it's kind of like adding. So that's going to give me a positive 22. 8 minus 2 is 6. So I've got my answer. 6x squared plus 22x minus 96. That's a tough question. All right, 6 and 7 still dealing with some area questions. Find the area of the white part of the rectangle here. Well, think about this. It's like I've got a hole in the middle. I need to take that hole away. So let's first find the area of that. This is a quantity, so I always tell my students put that in parentheses. So the area of the inside there is going to be a 4x minus 8. I can very easily find the area of the outside by taking these two and multiplying those together. So that's going to be, distribute the x, and now distribute the 6. Combine like terms if you have any. Okay, got the area of the outside, area of the inside. I need to take this away. Taking a -8 away is like subtracting a negative. If it helps, again, write it how I wrote the last question. I stack them up. I need to subtract this. I need to take it away. -24 minus a negative. When you subtract a negative, it's like adding. So -24 plus 8 is a -16. 2 minus 4 is a -2x. X squared doesn't have anything to combine with, so I get a final answer of x squared minus 2x minus 16. Number 7, very similar question, except this time I need to find the area of gray. So let's find this area by multiplying these two together. And here's where I'm going to start to make things quicker, because you guys have had lots of practice with this by now. We can multiply these two together to get the outside area. That's going to give me 12x squared minus 21x plus 8x minus 14. Combine your like terms. 12x squared minus 13x minus 14. That's the area of the outside. Inside is going to give me a 6x squared plus 27x plus 14x plus 63. Together that gives me a 6x squared plus 41x plus 63. I need to take this away from this. Again, if it helps, stack them up. You're subtracting, so you might have to deal with double negatives. You might also have to get your calculator out. Okay? -14 minus 63 is going to give you a -77. A -13 minus 41 is going to give you a -54x. And 12 minus 6 is going to give you a 6x squared. All right, that takes us to 8 and 9. 8 and 9 are LCM GCF questions. Got your calculator handy? I would get it out. Okay, so having my calculator handy, that means I can easily find the LCM of 15 and 16. I'm going to do that by going to my calculator, hitting the math key. Math key is on the left side here. Scroll over to the number column. Now, if you have it memorized, you don't have to go all the way down, but remember, it's option 8 down here. So go ahead, hit enter. You can only type 2 numbers in at a time, and you should separate them by a comma. And the LCM is 240. Now, the trick I tell my students, M does make you think of the word multiple, but I want you to make it also make you think of the word most. It will help you with your variables. What's the most? X to the 4th or x squared? Well, x to the 4th is the most. It's more than x squared. What's more? Y to the 10th or y to the 6th? Well, y to the 10th is more. And that's where I get my LCM from, because remember, this number has to be able to be divided by these evenly. If I don't take the most amount of variables and I go to divide by a y to the 10th, it's going to give me a negative exponent. And that's not what the LCM is involved with. Okay. Number 9 here, finding the GCF. Very similar place, math. Scroll over. This time it's option 9. And I know in your calculator it does say GCD. But same idea as GCF. 124, comma, 22 gives me a GCD or a GCF of 2. And then same thing. The F, I know it stands for factor, but I want you to think of the word fewest when you see that. I need to take the fewest amount of variables. X to the 8th, x to the 3rd. So I need an x to the 3rd. And then what's fewer, y squared or y to the 3rd? Well, that would be y squared. The reason why I need to take the fewest is because this has to divide these terms. If I took an x to the 8th and I go to divide x to the 3rd, I'd have a negative exponent and it would become an issue. That's why we use those little tricks that I showed for you there. All right, I think this is the last page. It does include a doozy though. Number 10, surface area and volume. So first of all, two different things here. Volume is easier. Volume is length times width times height. So I need to multiply all three sides. They're all quantities. I'd put them in parentheses. You can't, for example, I do this all the time with my students. 5 times 2 times 10. Nobody just knows, oh, that's 100. But what people do, and some people are quicker than others, what they're doing is they're multiplying the first two numbers together. They say, oh, that's a 10, and 10 times 10 is 100. And they get that answer really quick. But nobody multiplies three numbers at the same time or four numbers at the same time. You break it down one at a time. So same thing here. Don't try to multiply these all at once. I see so many people do this, and they write it out, and then they try to do these crazy distributing lines, and it's nuts. No, don't do that. Just do two things, get an answer, take that answer, multiply it by the other thing. X times x is x squared, negative 3x. Now let's distribute the 8, and let's just wait on this. Just hold off on it. Let's combine our like terms. I get x squared plus 5x minus 24. Now, a lot of people would prefer to multiply the binomial times the trinomial, although order doesn't matter when you multiply. But some people just like it because it's easier. So if you like it that way, just rewrite it. Put that in front. But it is the same concept. You got to distribute every term from this group into every term from this group. So x squared times 5x is a 5x cubed. X squared times negative 3 is a negative 3x squared. I'm done with that. But now I have to distribute the 5x. So 5x times 5x is a 25x squared. 5x times negative 3 is a negative 15x. I'm done with that, but I got to distribute this yet. Negative 24 times 5x is a negative 120x. And negative 24 times a negative 3 is a positive 72. Now I can combine all my like terms. I get the 5x to the third plus 22x squared minus 135x plus 72, and I end up with my final answer. All right, don't do too much. This is why I said it's a doozy though. We are not done. That was just volume. I've got to find the surface area now. Remember, surface area is the area of every surface. And keep in mind, this is a three-dimensional figure here. And so I've got something going on like this where I actually have a front, a back, a right side, a left side, a top, and a bottom. But the reason I said it the way I did is because the front and the back, they're the same thing. The right side and the left side, they're the same thing. The top and the bottom, they're the same thing. So if I can just find the area of one of those three sets of sides, I can double it, and then I would have the entire surface area. So let's find the area of the front. Let's find the area of the left side. Let's find the area of the bottom. Add them all together, and then just multiply by 2, and that'll give me the area of everything. So let's start with the front. The front I would find by taking my 5x minus 3 and multiplying it by the x plus 8. So that's going to give me a 5x squared plus a 40x minus a 3x minus a 24. That's going to give me 5x squared plus 37x minus 24. Okay, that's just the front. Now I have to find the left side. Left side would be x minus 3 times by the x plus 8. Good news, I'm going to cheat here a little bit. I did that already. That was x squared plus 5x minus 24. That is the left side. And then, so the front and the back are the same. The left side and the right side are the same. So when I go and double these, I'm essentially going to find those two. I'll find those two. So I already have 4 of the 6 sides. When I double, I haven't doubled them yet, but I still need the top and the bottom. So let's find the bottom and essentially the top, same thing, by multiplying that 5x minus 3 times by x minus 3. So that's going to give me a 5x squared minus 15x minus 3x plus 9. Combine those together, and I get the bottom. Okay, I'm getting closer. Let's add them all up to get the front, left, and bottom, which is 3 of my 6 sides, but those 3 sides are the same as the other 3 sides, so then I can just multiply by 2 and get my final answer. So let's add them all up. I've got a 5 plus 1 is 6, plus another 5, I've got an 11x squared. 37 and 5 is 42, minus 18 is 24. And a negative 24 and a negative 24, which is a negative 48, plus 9 is a negative 39. And now I can take this, which is the front, the left, and the bottom, and I can double it to find the final answer for the surface area. There are other ways to do that. There are specific surface area formulas, but that is the most generic. You have to find the area of every surface, and in this specific question, some of those surfaces were the same, which is why I was able to multiply by 2. Last question is kind of like a critical thinking question. What would A be if when I multiply these two things together, I get this? Well, do what you know. It's just an A. You can multiply that. X times x is x squared minus 2x plus ax minus 2a. 2 ways to think about this. First way is, that's going to be my constant that's equal to this. So what's a have to be? Well, a lot of you know already. That means a has to be 3. But the other way to think about it too, these two things have to combine. Negative 2 plus what is going to combine to give me 1? Well, negative 2 plus 3 is going to combine to give me 1. And that's your thought process with these questions. I know this was easier than some of the other ones we looked at in this class, but that's your thought process. That wraps up the Unit 5 review. We've only got 2 units left. Good luck on your Unit 5 test, and as always, if you still have some questions or you need some extra help, you need to talk to your teacher.